unfortunately, I'm not going to have this in full screen because we're going to kind of bounce back between Notepad++ and PowerPoint. We'll see. Okay. So, the first thing we're going to do today, we're going to slowly start walking through how to set up WebGL. Now, again, there are two pitfalls to this. One, you don't understand what's going on, so you can't get WebGL to work. Or two, you can get WebGL to work because you've looked at a different code and you've set it up monolithically, but then it doesn't scale beyond the example you've done. So I have posted a movie that was a pretty good movie on how to start getting something to render on WebGL. But again, the problem with this is it's, for instructional purposes, it's done monolithically. So if you have trouble with the API calls, if you have trouble with the like understanding what different moving pieces are, please look at the movie. Like it's a movie posted on YouTube. It's actually a really good tutorial, and it will help you get you so WebGL can work. But you want to take the time right now to make it into an object, into a class like we were talking about, and so we can scale this solution up when we get to more complex scenes. Because we're going to do more than just render triangles in this class, I promise you. So, again, this is the only problem with teaching WebGL is the learning curve, which is right now. So we're going to kind of walk through this very, very slowly and thoroughly, and once it's set up, I believe what happens usually is most of the like some minor details you may not understand will eventually make sense as the class progresses. But it's a lot, you have to do a lot to get it to start up, to get it to boot, so to speak. So the first thing we're going to do is we're going to set up our canvas object, and this is going to be just like we did with the 2D context. Now, if you have the example I gave you, you already have this. So if you download that example from Canvas, I don't think it's called 3D, I think it's called something else.
WebGL version A.
Yeah, WebGL version A, there you go. It should have this in it, but basically we're going for the, we have a canvas, we're going to give it an ID, and then we're going to try to get context from it. So right off the bat, we have to get the WebGL context from it, and that's going to be achieved. Some of this may not be worth going back to PowerPoint for. We'll see. You know what? I think I'm going to just stick with the Notepad++. I think it'll make more sense that way. So right here, we are going to basically have the two global variables I will allow, that I think you should allow. You have the canvas object because you're grabbing the, and I'll be honest, any HTML object variable you need, you can make that global, assuming it has a very unique name. But if you need to grab the canvas, we do that with get element by ID, and then we're going to get canvas.getContext just like we did with the graphics 2D, except this time this is going to be WebGL. And there's actually a couple other things we can type here, like WebGL experimental, but I think all browsers are up to date now, so we should all just use WebGL. This time, instead of calling the context CTX, we're going to call this GL, kind of basing it off of OpenGL. Like all the GL functions have a GL dot in front of it. So we kind of, most people just call it GL. We're going to use this variable quite a bit, and so for convenience sake, this one makes sense to have as a global variable. So we're going to set up our GL context right away, and now we have access to the GL, the way to the GL API. Unfortunately, we're not ready to draw yet. In fact, we're not going to be ready to draw for a while. I have a main function here, which, to be honest, I should make this a class, but let's see how do I want to do this. What do I want to introduce first, shaders or the interface? Okay, let's do that. So at the top of the file, you should have, I think you have this too. You may not have this part, but you should have this anyway. You're going to have these two scripts, and they're going to say not JS. So type is not JS. That means the web browser is going to ignore the script tag. These are going to be GLSL code. So yes, surprise, you actually have to know a different language as well in this class. GLSL is a shader language. We are going to have to play in this realm a little bit, but we're going to kind of work our way into it. So it's not going to throw a lot at you right now. There are basically four different, if I remember correctly, four different types of variables. Yes, the five, I guess. So you have attributes, buffers, uniforms, textures, and variant. What we're really going to be worried about, the buffers are going to be data we've loaded into the GPU to run, like vertice information, possibly normal information, and we're going to use that to kind of access and draw different things. Uniforms are going to be variables that we can set, but are not part of the attributes, not part of the vertices. So you'll see there's two ways we can set properties. We can just have this uniform variable that we can call, or we can ask GLSL to set for us, so it'll do something, or we can set it in attributes, which is going to be inside the vertice information, inside the buffer information. So if you think of like a buffer, we might have vertices X, Y, Z, and then we might have color X, Y, Z, or RGB. So if we do that, we need an attribute, because the attribute will be reading that property value from the vertice information itself. The uniforms are not necessarily, they're pretty much global variables in a way, but they're not going to be set, or they're not going to be restricted to each individual vertice. Textures are going to be exactly what they sound like. Textures we can wrap our data around. We're not going to be seeing textures to the end of the semester. And then varying is, these are variables that we can pass from the Vertex Shader to the Fragment Shader. And so the Vertex Shader, this is responsible for determining where the final point is in the world, where the final point is on the screen, or where the object is, and passing any attributes it needs to into the 2D Fragment Shader. The Fragment Shader deals basically with color and lighting, which is the same idea. So we'll have both of these will be necessary to use. We'll be focusing a lot with the 2D Vertex Shader at first, and then we'll move to the Fragment Shader when we hit textures and colors, or lighting, really. So what I am saying here is what we're going to do is we're going to take in a vector 4, and this is going to be attribute position. This means it's an attribute, we call it a position. This means I'm reading it in from the vertices. And then I've inside my main function of the Fragment Shader, the Vertex Shader, I'm going to assign that to GL underscore position. This is the last line I'm going to have in my main function. When I assign something to this position, that's the final position in which it's rendered. So right now, I'm just kind of doing a pass-through. Whatever coordinates I specify just get set to that, and then we're done. Really, really easy. Now you're probably thinking, well, wait, if I'm setting the coordinates, why would I want to change it? Well, what's going to happen here is you're going to model say you're modeling a triangle, and it's going to have the points 0, 1, negative 0.5, negative 0.5, and 0.5, negative 0.5. But you may want to move that somewhere else in the world. So even though that's your model vertices, that's what it would look like, that's not going to be the final position of the shape. You're going to want to model that or move that possibly, or possibly scale it or rotate it. And so the GL position and the position of your vertices are not always going to be the same. Does that make sense? So here we're going to have, you kind of think of a sloppy version of C++. We have a global, this kind of acts like a global variable, but it's just really just for this. We have attribute vector 4, it's an attribute position. It's going to be x, y, z, and a fourth variable, which we're not going to worry about right now. And then here we have our fragment shader. And since we're not reading anything in, one thing we have to do is say precision medium float. I'm not entirely sure why we have to do that, but we just have to say we have to have that there. And all the fragment colors are going to be between 0 and 1, not 0 and 255. So 1, 1, 1 is white, is 255, 255, 255. 0, 0, 0 is black. 1, 0, 0 would be red, RGB. So in this case, and the fourth value is going to be my alpha, which 1 is not opaque, 0 would be completely invisible. So I can actually set transparency here. So RGB, B is 1, so this is going to be blue. I'm just setting everything to blue, and it's not going to be opaque. So again, really simple, really, really simple fragment shader. I'm not even sending information into the fragment shader. I'm just, here, deal with it. Just make it blue. Now, if I was sending information into the fragment shader, and say 2 different vertices had different colors, the fragment shader can do this really neat thing where it will transfer between one color to the other. So it'll go most
Gradient?
Gradient. So you'll do, so if I have like green to blue, you'll see a green to blue gradient. Thank you. That was the word I was looking for. So it will blend the colors together between the vertices, which is a really neat little feature. But right now, everything's blue. So everything's going to be blue. We don't have to worry about that. So when we get a little bit further, you'll see that we are going to be taking in a couple different steps. And this, again, is going to be right before the rasterization. In fact, I think I have that slide. That might be a useful slide to talk about. So here we're going to initialize, this is a little bit simplified. We're going to update the world model, which means we're going to update where the camera is, if anything moved, but basically we'll deal with that later. We don't have to worry about that, that's not required. We're going to set our attributes, which are going to be actually from our vertices, or from how we read our vertices. Then we'll set which buffers, uniforms, textures, and diagrams we need to use, or programs, which we only do the program once, but we're going to set our state variables, set up how we want to do it. we're going to specify WebGL to draw some points. When we draw points, these attributes are going to be, oh, I missed my arrow, sorry. Go to the Vertex Shader, and these points will then be transferred into what they are in the world space. And then they go to the rasterizer, which is you draw the points in between the vertices, and then you go to the Fragment Shader, and that's when you apply the color to it. So the Fragment Shader will be pretty much the very last thing except for the finally buffering into the frame. So this is the overarching goal of what we want to do, but in order to make this work, we have to make the Fragment Shader and Vertex Shader, and we have to tell WebGL how to make that work. So that's a little bit of a challenging component, is getting this set up. But once we get it set up, everything is very similar to what we would do at OpenGL. So this is why this is that extra step we have to kind of do. Now, going back here. So I'm going to come back and we're probably spend a little more time here, but just remember we have, it might be worth your while to look up GLSL and just look up the basic data types they have. I will expect you to know matrix, a 4x4 matrix. I will expect you to know vector 2, vector 3, and vector 4. I will expect you to know the difference between attributes, uniforms, and varying. And everything else I think we can kind of learn as we go. Again, I told the last class, oh, don't worry, we're not going to spend too much time here, and then we ended up spending a lot of time here with lighting, and I felt bad. But so we will spend some time here, but it's kind of one of those things we'll kind of learn as we go. Right now, all we're doing though is we're just taking in the position from the vertices and saying that is the final position of our shape, which has some problems, but for now that would be fine. So these two scripts are available on the web page. And basically what I have to do now is I have to compile the GLSL through JavaScript. And that is as tedious as it sounds. Yes. So this will get to the other portion, is setting up, or how to set up the WebGL. So we have our shader set up, and in our JavaScript we have our GL context. We found our GL context. Now we have to kind of make this happen. We have to make this, combine these to get this working. So what I would recommend is make a new file. And I've called mine, let me find it. Hold on. Oh, yeah, and you need to import it after the shaders. I called mine WebGL underscore interface.js. You can call anything yours anything you want. And what we're going to do is we're going to set up our WebGL. Now, remember how JavaScript functions. JavaScript is going to function whatever has been declared will have been declared. So it's not necessarily a placement thing, it's whatever's been run. So this is going to be imported, but by the time I call this constructor, my GL variable will have been created. So I'm expecting, this code is expecting to have a global GL variable. If I don't, then it's not going to work. So that's why I had to set up the GL variable first, then call main, and inside my main function, I'm going to invoke this constructor and set this up. In fact, I'll show you that now. I'll come back here, don't worry. So down here I have GL canvas. This is where I get my GL. I call my function main, and then inside main, the very first thing I do is I create an instance of my WebGL interface. So that's how the constructor is getting called here. Now, I need a couple variables. We don't have to, really, this is, the naming convention here is up to you. This is, everything in JavaScript, you can is kind of yours to control. If you want to use a list, or if you want to use an array, if you want to use whatever you want to use, you can do it, you can store data however you want. In GL functions, you have to meet their standards. So the easiest way to do this is I need to get the source code for my Vertex Shader. And so what I can do is I can get element by ID. If you remember right, we called that script tag 2D Vertex Shader. That gives me the script content, and I can say .text, and that will be the source of my Vertex Shader. Likewise, I can do that with the 2D Fragment Shader and get the .text and store that to the source. This part or this part?
Yeah, that part.
Where it come back? Okay.
Does it just like end there with the semicolon?
It's a mystery. No. Okay. So I've created two helper functions, create shader. These are my functions, these are not built-in functions. And I'm going to send in what kind of shader I want to create, and I'm going to send in the shader source. So the first one I want to create is gl.vertex shader, and the second one is gl fragment shader, and then the second parameter is the appropriate source for both. Does everyone understand how I'm getting the text for this? I'm basically grabbing the object with the document object model. Then I'm getting the text inside the script tags, and I'm using that as if I typed that out, or if I had that on file somewhere. That's going to become the text I'm going to try to compile. So when I have these two helper functions, I'm going to create shader and send in the type of the shader I want, which is a integer flag in GL, so gl.vertex shader, gl.fragment shader, and then I'm going to pass in the appropriate sources to my helper function. You'll see, after going through this, you'll see that when people do this online, they have this just giant mess. They basically copy and paste this twice, and it's just very cumbersome. But here we're gonna have to create a GL shader. So we're gonna say create gl.create shader and what type. Remember, type is my parameter, so I pass that in. So I passed in what type. In this case, it'll be a Vertex Shader first. Now, remember the state machine. Actually, no, we haven't got state machines yet. Don't worry about that. So I created the shader, and then kind of using a C-style function, I'm going to set the shader source. But remember, OpenGL was not designed with objects. So I have to pass in the shader, and that I want to modify, and I have to pass in the source. So I can do GL, so again a shader source, gl.shader source, and I'm going to pass in the shader, and I'm going to pass in the source, and this is going to tell GL that, okay, this shader has this source. This is how I'm going to set the source to that shader. And then I'm going to do gl.compile shader and specify which shader I want to compile again. So I'm compiling my original shader. And then I could, if I want, just pretend like it's going to work and move on. However, how many times do you ever compile a program and it doesn't work? Does that ever happen to anyone here? So that can happen here too. Now here's the tricky part. GLSLs working in your graphics card, it's happily moving on in its life, it has no need to contact JavaScript. Like, oh, it broke. So JavaScript will have no idea whether or not it worked. So we use this, we have var success, GL get shader parameter, and we do shader, specifying what shader we want to test, and we want to do gl.complete status. So what's the completion, or compile status, pardon me. What's the compile status for our shader? If it's true, if this returns true, then we can just say return shader, and we now have our whatever shader we were trying to create. This would be a good thing to copy down if you don't have it. I don't know if I don't think I have it.
You put it into a function on the one on Canvas.
What?
If this, the class here, or is it like 3 separate functions on the, like you put on Canvas?
Oh, okay.
So we don't
Okay,
have
so
it.
you do have it. Okay.
Yeah.
So this is the OOC version of the one I have on Canvas.
Okay.
So I would recommend setting it up like this to make your life easier. But you can you reuse the functions.
It's like, I got everything from earlier, but there was like a few lines that I guess went over like right before this date.
Like in the constructor?
Yeah, like,
We'll go back to constructor.
okay, yeah, like just a few lines of the really
Yeah, we'll go back to the constructor in a minute.
Okay, yeah, like use program stuff.
Okay. So if it's successful, we return the shader, and this object will, this variable will be returned to the constructor, and we'll set our shader that way. And then if it's not, we're going to do console.error get shader info log, what shader we need to deal with. And so this will actually stop the program. I think about this should go up. And then we can do gl.delete shader to, but this actually isn't going to execute. So I guess you can make this a warning and then run this. It will actually delete the shader. I made this an error, so the JavaScript just stalls out. So in this case, this line won't be executed, but just to be formal, you have delete shader. That will remove that from the memory and delete it from your graphics card. And this will only happen if it didn't work. Now, back up here. You notice that when I call this function, I return it to this .vertex shader or this .fragment shader. So I'm now storing the actual compiled vertex shader and fragment shader from this function. Now I'm not quite done though. Just like a C++ program, I've now compiled 2 separate .cpp files. I have 2 .o files. Now I got to link them. Yes. Did I do that?
Yeah, you have Fragment Shader.
Yeah, so I misspelled that. I'm sorry, but I think I consistently.
Consistently
Yeah.
spelled it.
Fragment. Yeah. Okay. So I consistently misspelled that. Yes, I'm sorry. So yeah, there's a T. But this is my variable, so it doesn't matter. But I just have to make sure I don't don't spell it correctly then. So then I have my .o files, and I need to link them together. And just like here, it's going to bother people, so I'll just change it. Okay, I think it's the only 2 times I need that variable. So in this case, I made another function called create program. And so, by the way, the reason I'm making all these helper functions is if I didn't make these helper functions, then that code you saw down there would have been repeated twice just to get this information. And then I would have had the code in the create program function and set it here. And what would have happened is this constructor would have been about a page and a half long, maybe a page. So the reason I'm making these helper functions is to modularize my code, and if I have to debug, I can isolate it down to where the problem might be. So I created a function that I'm going to pass into two different shaders I've compiled. You can kind of think of this as a .o file. And now I've got to link them together, and I'm going to get a program, a GLSL program back. And this program is actually going to be what is used in our rendering. This is kind of like the end goal of what's going on right now. So that's good. We're almost done with this component of it. So if I go down to create program, I send in Vertex Shader, Fragment Shader. I'm going to create a GL program to my variable. And then I have to specify which shaders I want to attach to my program. So I'm going to attach, and I have to specify the program. So the program I created, and then the Vertex Shader, attach shader, Fragment Shader, and then I have to do gl.link program and specify the program I want to link together. This would be the linking stage of C++ compiling. Now, just like we did with the shaders, if an error occurs, then I'm not going to know about it. So I have to determine, so var success equals gl get program parameter program, what program checking, gl.link status, the linking phase. So we'll see how did it link together. Did it link, what's the status of linking? If it was successful, then I return the program. Otherwise, I cause an error, and I should delete the program as well. But I mean, if I make this won't run because that's an error. But if I log, it will run. So the same idea, but this is the linking portion of the compiling process. Any questions with that? I mean, I understand that you may not have the syntax memorized. I actually wouldn't expect you to memorize the syntax, but do you understand what's happening right now, at least on a concept level? Yes? Okay, so this program variable is going to be the thing that we send back. And this is the thing that we're really looking for. So assuming it works, I go back to my constructor, then I'm going to set this dot program equals the return value of create program. Are you okay? All right. And then I can set my GL viewport, which basically sets what's the viewport in my canvas, which for now will be 0, 0. And then I can do GL canvas width, GL canvas height. I can do what my clear color is going to be when I clear the canvas, which in this case will be white. And then I can do GL clear and just clear out whatever, if there was anything in the canvas, I can go ahead and I can just specify that GL.color or clear out the color buffer bits. And then I need to specify what program I'm using to GL. And so GL.use program, and we use the program that we compiled up above in the constructor. And now we've told, now we've set up a rendering program in GLSL to render our WebGL. So again, a lot of moving parts to get to do anything, to get to the point where you do anything with WebGL. But once we get this, a lot of it can be reused. In fact, all of this can be reused for the rest of the semester. We might add 1 or 2 flags here like clear or depth test and stuff. But other than that, this code here will remain unchanged. So once we have this program, we tell GL or the WebGL we're going to use this program, and then we're done, except for the fact that we will need to access this .program again. So we will have to make sure we keep that variable available. But it's okay because this is now an instance of my WebGL interface class or instance. It's now an instance variable. Any questions with that?
I think it was like the bottom maybe at the end of long so you have to write like what that does.
What do you mean what does?
Like, is there anyone that in that code that you've written what the program does?
No, I have not added comments here, I apologize. Is that what you're asking? I can't hear what you're saying.
Like, where do you define delete program?
Okay, so anything that starts with GL, this is a WebGL function.
Okay, cool.
Yeah. So, and again, some of the APIs at this point in the semester, I wouldn't expect you to have all of the GL API memorized, but yeah. So anything that starts with GL dot is the WebGL API. It's not my own thing.
Okay, that was a good.
So we're good, right? Now we just have an array of a bunch of vertices, and we can draw whatever we want and have a lot of fun, right? Well, not quite, not quite. There's one more little catch. We're not quite ready to start drawing stuff. Well, we actually are ready to start drawing stuff. Just the process of drawing stuff is going to be a little more complex. So this is, by now, you've already seen the primary difference between Context 2D and WebGL, right? Context 2D is like, here, draw circles, draw lines, it's fun. This is, well, we have to compile something first, and then we have to set up how we're going to draw things. So it's a little bit of a little bit different world. So going back to our main function here, here is my WebGL. And what I'm going to do is I'm now going to create an individual class. I actually created two classes in one file, but I should have two files. And I'm going to create an individual class for each shape I want to draw. So this is why I was saying it divides out fairly nicely. If you have your main, and I should be honest, this is your main class, your callback functions for HTML input, and your shaders in your main HTML. It's a fairly reasonably sized file. You have your WebGL interface file for setting up the WebGL. It's like a page and a half. And then if you have an individual file for each object that has its own class that you're going to draw, it's actually a fairly short file. Especially if you employ inheritance, which I don't do. But sorry, what? Okay. So I have these two classes, and then in each of these classes, I'm going to have a render function. Now my render function is going to need the WebGL program that we just got done doing. So but that's okay because with the power of OOC, I have my instance of WebGL and .program. I can pass that variable into each of these render functions. You'll see a lot of people will make the program a global variable, and you could. That would be one of the 6 one way, half a dozen the other, because you do use the program in different rendering. The problem with this is you are now relying, if someone else wants to use your code, you're now relying that they're going to have set up the program as a global variable and the GL as a global variable in order for your code to run. And this way, they know they have to pass in the program for the WebGL if they look through this code. So this is a little bit more modularized than just having a second global variable, but many people will make this a global variable because it is used on occasion. So let's look at triangle 1. Like I said, there's actually 2 classes here. So in the triangle 1 class, I have the constructor. And now this is, although you're not going to see, actually no, never mind, I'm getting ahead of myself. I won't talk about that yet. Now here, I'm going to set up how to draw my triangle, what I'm going to draw, and any information I want regarding this triangle. Remember, I have not set any sort of scaling or any sort of world coordinates or world matrix. So everything I draw right now, it has to be in the world of -1 to 1 in all axes. I cannot go beyond that. I mean, I can, but nothing's going to happen. Nothing's going to draw. So the first thing I'm going to do is I'm going to create a buffer. Now, I want to do an experiment this summer because I feel like there's a more optimal way of doing this, but this is a good learning and teaching moment. I want to create a buffer, and this buffer is going to hold the information for what shape I'm trying to draw. And it's going to say gl.bind buffer, and now this is where the state machine comes into play. Remember, this is OpenGL and WebGL. There is no object context. There is no myBuffer.setVertices function per se. So whatever the last buffer that was bound with this function, GL bind buffer, so an array buffer, this dot buffer, whatever the last buffer that was bound will be affected by the buffer functions. So if I forget this line here, the previous buffer I bound, if I have one, will now be affected. So bind buffer is basically telling your graphics card, you are now using that buffer. If I have any sort of buffer function, you modify that. If I forget the bind buffer, then whatever I was previously pointing at will be modified. Does that make sense? So it's just like a state machine with like the set color or set line width. Think of this as setting which buffer you're going to modify. And if I forget to change which buffer I'm modifying, I'm going to modify the wrong buffer. So gl.bind buffer, this is one of those functions you do need to kind of commit to memory and understand. Is you get the buffer type, which I think in our case will almost always be array buffer except for elements, which we'll get to later. So I think it almost always will be array buffer. And then this dot buffer, or the buffer variable that we created with the buffer. So now we've set the state machine to say, okay, this is the buffer that's currently active or currently being modified, I should say. So we define our vertices. And we have 0, 0, negative 0.5, 0.5, 0, negative 0.5, 0, 0.5, 0.8. And it's basically it's actually a 1D array, but it's set up as a 3 XYZ coordinates. So it is a 1D array.
So why do they use 1D arrays as opposed to 2D arrays?
It's a good question. It's actually an optimality thing. It's easier to bring in a buffer and represent everything as a 1D array coming in, and it's just smoother. So it's actually a optimality thing. Plus, in this, if I remember correctly, all of this will be contiguous data, where a 2D array will not be contiguous data. So you want to streamline the process to go to sending the vertex data to the GPU. And this is quite common. You'll see this like in OpenCV. Anyone ever did computer vision? So OpenCV does this a lot, right? Like their images are 1D arrays.
Well, at least the newer versions, there's a matrix data type that's a 2D array by default. So,
Oh, okay. It's been a while. But I remember they used to have like their convolution matrices used to be 1D arrays. So you will see this pattern a lot where you just make it a 1D array because it is a little more optimal. And the reason this is important is in this, our silly little example right now, is not even going to break a sweat for our computer. But if I'm running the newest, Call of Duty 45 or whatever they're on, now I've got umpteen million vertices. Now it's important. And this is where I set my attributes for each vertice. So I could have color here of each vertice. I could have texture UV coordinates here. I might even have normal data here if I wanted to. And so now my vertices are going to become very large very quickly. So when I set the buffer, I have to make sure I have the correct buffer bound. Then I buffer the data. This is where I actually set, okay, this vertice information goes to this buffer. And I'm going to do that by buffer data. It's an array buffer, and I have to cast everything as a float. Now, in JavaScript, everything's a double. So I have to say new float 32 array, this dot vertices, so I cast it to a float 32 array. That's one of those little things that you didn't know about, it would haunt you. And the reason graphics engines use float instead of doubles is it's quicker. Computationally, it's much quicker, and to be frank, you don't need the precision. Like, how many times, because I can't go to the 12th or whatever the digit is on the floating point, my game won't work. That's usually we're not usually worried of that kind of precision. So you'll see game engines and graphics engines will just use floats. Because we really, our eye we wouldn't even be able to tell the difference. We wouldn't even be able to render the difference on the screen. So we cast our this.vertice array into float 32 array, and then we're going to mention that this is going to be a static draw function. Pretty much everything we do can be static draw in this class. I don't think we're going to have anything dynamic. So we can just keep this can stay GL static draw. And now we buffer the data to the GPU. But an issue we want to make sure is we only want to run this once. And so you notice that it's in the constructor. We are buffering data once. We do not want to do this every frame. Because even your super powerful computers, if we do this, let's say eventually when we get to more advanced code and we have a bunch of, say the maze game, where you just make walls out of boxes, if we buffer this vertice information to the GPU every frame for each box, your super powerful gaming laptop will not be able to handle it. It will start to lag. And the reason is not because the CPU's weak or the GPU's weak, it's just that to transfer, this is going from CPU to GPU. So buffer data is one of those functions that go from CPU to GPU, and that is going to take time. And that's going to go through a system bus, and that's going to just be slower than normal processing. So anytime you're buffering data or putting data on a buffer, whether it be an element buffer, which we'll talk about, whether it be, there was one more, a texture, we are setting a texture, you want to do it once. You do not want to do it every frame. Now, the other thing too is if I was going to reuse this object, I think, and I have to test this, I think it would be good to, I think all the objects could use the same set of vertices in the same buffer. So right now, if I made multiple instances of this triangle, each triangle would have its own buffer. I believe you could set it up so all the instances of the object use the same buffer and thus reduce the memory load on your GPU. I want to test that out this summer. I'll try to set up an experiment. Because I noticed, like for example, the last assignment will be, again, the primary object is a box. And so, since everything's a box, just different textures and you know, why not have one buffer? You see, there's no reason to have, I don't know, 200 by 200 divided by 2 buffers in your GPU. They're the same exact shape. I have to test that out though. I want to run an experiment. But for now, and actually your GPU won't have any problem with handling the final assignment either. But for now, make sure we're only buffering data once on the initialization, and make sure we're not sending data every frame. That's the takeaway for this. Once I have that finished, then I can go and worry about how do I draw this. So now I've specified the buffer that will actually render the shape, and now I have it loaded into the GPU. Now I have to worry about how to render. And for that, you guys will have to come back tomorrow. All right.
Joel, just a little bit over.
To be
Or
continued.
can you,
Sorry, what?
can you break up that line position attribute?
You know, I wouldn't worry too much about this because I'm going to go through this really fine tooth comb tomorrow.